Hi, good day. So this is a discussion for one application of differential equation. This is for a mixing problem. Okay, so let's have this example situation. Consider a tank which initially holds B sub O gallons of brine. If you say brine, that is a water salt solution. That contains A pounds of salt. Another brine solution containing B pounds of salt per gallon is poured into the tank at the rate of E gallons per minute, while simultaneously, the well-stirred solution leaves the tank at the rate of F gallons per minute. So let's have the illustration of those first few sentences. So we have the initial volume of the brine is B sub O, and it contains an amount of A pounds of salt. So it contains A salt. Then we pour another brine solution at the rate of E, that is in terms of the volume over time, gallons per minute. It contains an amount of B of salt. Then we allow the liquid flow out from the tank at the rate of F. So that is also in terms of volume with respect to time. But for this statement, we don't have the concentration of salt leaving the tank. Let's say the concentration of this F, the concentration of salt leaving the tank is C. That will be the amount of salt leaving the tank. Then we go back. So we are now here. The problem is to find the amount of salt in the tank at any time t. Let Q denote the amount of salt. Let Q denote the amount of salt in the tank at any time t. So we say Q, the amount of salt. So let Q denote the amount of salt in the tank at any time t. The time rate of change Q, that is the dQ over dt, equals to the rate at which the salt enters the tank minus the rate at which the salt leaves the tank. The salt enters the tank at the rate of BE pounds per minute. So we have here the rate in which the salt enters the tank, that is the BE, in terms of the pounds per minute, according to that statement. So how do we express that the dQ over dt? This one. So basically, if you are to focus on the salt, that is the change in amount of salt with respect to time is basically equal to that is the volume in, or the amount of salt in, or maybe in terms of weight of salt in, minus the volume out, or we can have it as in terms of weight or in terms of volume. But if we are to use the BE, then that will be in terms of pounds per minute, then that will be in terms of the weight. And then we change this one. So let's say this is the weight in, then minus the weight out. So according to the problem, what is the rate of salt enters the tank? That is the BE in terms of the pounds per minute. So that is the weight in. We have BE. What about the weight out? So we have the rate of the solution coming out from the tank is F. And the concentration is C. So we say that the weight out, we can have it as, let's say, F times C. So that is minus F times the concentration C, or small c. How do we compute for the concentration of the salt coming out from the tank? That will be C is equal to the volume of the salt coming out from the tank, or that is the amount of salt coming out from the tank. This is to be divided by the total volume of the solution. So we are using Q as the volume of salt, or the amount of salt. This is divided by the total volume. What will be the value of C? That will be, or the total volume first. What will be the equivalent of the total volume? The total volume is that, okay, we have this initial volume, that is the B sub O. So that will be B sub O. We have a rate of volume entering the tank. So basically, okay, we have here, the volume in. That is, the volume is equal to E. That is, E is equal to the volume over time. How do you compute for the volume? That is, the volume, this is the volume in equal to, by cross multiplication, that is E times T. Then what about, the volume coming out? So this is again the volume in. What about the volume out? We have that as F is equal to the volume divided by the time. So by cross multiplication, this is the volume out equal to F times T. So this is the volume out. So therefore, what will be the equivalent of our total volume? The total volume is that, again, we have that initial volume B sub O. Then the solution enters the tank. So that will be plus the volume in, that is E times T. Then volume out, since it is coming out from the tank, we subtract F times T. So we'll be having the concentration of the salt leaving the tank will be C, that is the amount of salt divided by the initial volume plus volume in ET less volume out F, the FT. Then let us now have our expression. This is the rate of change of the amount of salt with respect to time is, that is the BE, then minus FC, that will be F, as equivalent of C, that is the amount of salt Q divided by the total volume, that is the B sub O plus ET, minus the F times T. Then we can simplify our expression. This is, let's say, dQ divided by dt is now equal to, or we can transpose this one, plus F, to be multiplied by Q, divided by B sub O plus ET, minus the F at T is now equal to the BE. So this will be our initial expression. Let us try to use this expression to one example. So let's have this example. A tank initially holds 100 gallons of a brine solution containing 1 pound of salt at time is equal to 0. Another brine solution containing 1 pound of salt per gallon is poured in the tank at the rate of 3 gallons per minute, while the well-stirred mixture leaves the tank at the same time rate. So, find A, the amount of salt in the tank at any time t, and letter B, the time at which the mixture in the tank contains 2 pounds of salt. So, let's have first the given. This is at time is equal to 0. We have the initial volume is equal to 100 gallons. It contains a salt of 1 pounds or 1 pound. So again, time is equal to 0. Initial volume is 100 gallons. It contains 1 pound of salt. So another brine solution contains 1 pound of salt per gallon is poured into the tank at the rate of 3 gallons per minute. So that will be the E, that is the 3 gallons per minute. So the amount of salt in that brine solution is 1 pound. That will be the value of B. 1 pound of salt. Then according to the problem, the well-stirred mixture leaves the tank at the same rate. So according to the problem, the value of E is the same as the value of F. This is the same as 3 gallons per minute. Then we try to substitute. So again, the concentration of salt leaving the tank is not given. So from our previous equation, This is the dq, the change of rate for the amount of salt, dq over dt, okay, plus f, okay, multiplied by the value of q divided by the b sub o, e times t, plus e times t minus f times t is equal to the b times e. Then I think we can now substitute. So this is, we have the dq divided by dt, plus what is the value of f, that is 3 gallons per minute. Multiplied by q divided by initial volume is 100 gallons. Plus e is 3. Our initial time is 0. Then minus f, that is 3. Initial time is also 0. Is equal to, what is the value of b, that is 1. Multiplied by e, that is 3. Then we simplify. So this is now the dq divided by dt plus, so this will be 0, 0. That is 3 over 100. 3 over 100, what is that value? 0.003 or 0.03. So it should be 0.03. That is, we have 0.03 of q is now equal to 3. So if you are to observe this differential equation, basically this is a linear differential equation. So let us look for its solution. Kindly recall the solution for a linear differential equation in our prelims. So what is the standard form for a linear differential equation? That is dy over dx plus the p of x of y is equal to the q of x. But basically this is already in standard form. So let's say dq over dt is equivalent to the dy over dx. The 0.03 is the p sub x and 3 is the q sub this is a q of x, and the 3 is equal to q of x. So again, for our better understanding, let's say the dq over dt will be our dy over dt. Then the p of x will be the 0.03. Then the q of x will be simply equal to 3. So for the solution of this linear differential equation, we can have it as the y equal to, this is 1 over the integrating factor I of x, then multiplied by the integral of I of x, q of x, dx plus the arbitrary constant c. So instead of using y, we use q. Then instead of using x, let us use t. So what will be the equivalent of our integrating factor? That is, instead of x, I'll be using t, since this is with respect to time. I sub t. That is simply equal to the integral e raised to the integral of p of x dx. But again, since I'm using t, that will be the same as e raised to the integral of, let's say, p of t dt. So instead of p sub x, what is the equivalent of p of x, or the p of t? So we are replacing this instead of x. Since this is with respect to time, I'll be using p of t. Then instead of q of x, let's say this is q sub t. So I hope that is clear. We are just using the variable applicable for this example. So what is the equivalent of P of t, or that is the same as the P of x. So we'll be having our integrating factor, I sub t is now equal to e I raised to the integral of, what is our P sub t? That is simply 0.03. The 0.03 of dt. What is the integral of 0.03 dt? Kindly recall your integral. So the integral of 0.03 dt, that is simply e raised to 0.03 of t. Okay. So by the way, again, this formula is the formula for the solution of a linear differential equation. So we can rewrite this one in terms of the variables we are using in this example. So instead of y, I'll be using q equal to, instead of I of x, that is I of t, then to be multiplied by the integral of, again, instead of I of x, that is I of t, multiplied by, instead of qx, that is, let's say, q of t, then instead of dx, this is dt plus c. So I just substituted the variables applicable for this example. So we may now substitute or simplify. This is now q equal to 1 over, what is the I sub I of t? So I of t is, that is e raised to 0.03 of t, to be multiplied by the integral I of t, that is the same as e raised to 0.03 of t, what is the equivalent of q of t? Q of t, or the q of x a while ago, that is simply equal to a constant 3. This is to be multiplied by 3, then dt plus the arbitrary constant c. So what is the integral of this term? So we may bring out that constant. We have now q is equal to 1 over e raised to 0.03 of t. Bringing out the constant 3, what is the integral of this term? E raised to 0.03 of t. If you are to recall our integrals, the integral of e raised to 0.03 of t is simply e raised to 0.03 of t divided by 0.03, the constant 0.03. So that will be 3 times its integral, that is e raised to 0.03 of t plus the arbitrary constant c. Alright, then we now simplify our equation. This is now q is equal to, we distribute this denominator to these 2 terms. Sorry, so I forget. What is the integral of e raised to 0.03 t? So we are to place a denominator. We have to place a denominator of 0.03. Then we are now to distribute this denominator to these 2 terms. So that will be q is equal to, this is 3 e raised to 0.03 of t divided by 0.03 of e raised to 0.03 of t plus, this is c divided by e raised to 0.03 of t. Then we simplify. So we have now the equivalent of q. So this is q. We may divide that. That is 3 divided by 0.03. That, I think that is 100. That is 100. Then we may cancel this term. The e raised to 0.03. Then plus, this is, how do we bring this denominator to the numerator? We just need to change the sign of its exponent. So that will be c multiplied by e raised to negative 0.03 of the time. So we'll be having, this is the q of t. The amount of salt at any time t is now equal to c e raised to negative 0.03 of t, I just move this 100 to the right end, that is plus 100. So the next thing to do is to compute for that constant c. So again, such a long derivation. So again, initially, at time is equal to 0, what is the amount of salt? That is A. We have 1 pound. That will be the value of, that will be the initial value of Q. The value of A. Alright, so if you are to recall, at time is equal to 0, the amount of salt in the solution is 1 pound, and this will be our Q. Okay, the initial value of salt in the solution. So we substitute, that is, from this equation, the initial amount of salt is 1 pound is equal to C. This is e raised to negative 0.03 of t. That is, at time is equal to 0, we substitute. What is the value of time? That is 0 plus 100. So we know that, negative 0.03 times 0, this is the same as 1. So we have, this is now 1 less 100 is equal to C. The value of the constant is 1 minus 100 is negative 99. So therefore, we'll be having our working equation. The working equation will be Q at any time t is now equal to the value of C is negative 99 e raised to negative 0.03 of the time t plus 100. So this will be our working equation. The amount of salt at any time t. So this will be our working equation. The amount of salt at any time t is equal to negative 99 e raised to negative 0.03 of time plus 100. Then we proceed to the second question. This letter B. For letter B, the time at which the mixture in the tank contains 2 pounds of salt. So we go back on our working equation. So we are looking for the time. Again, this is for question letter B. We are looking for the time wherein the amount of salt will be equal to 2 pounds. So from our working equation, we substitute. So that will be Q sub T, or the amount of salt, that will be 2 pounds is equal to negative 99. This is e raised to negative 0.03 of the time plus 100. Then we are solving for the time. So what will be that value? That is 2 less 100. 2 less 100 is negative 98 equal to negative 99. This is e raised to negative 0.03 of the time. So we divide both sides of the equation by negative 99. So we'll be having the equivalent of 98. This is now positive 98 divided by 99 is equal to e raised to negative 0.03 of the time. For us to bring down that exponent, we are using natural logarithm. This is the ln of 98 divided by 99 is equal to the ln of e raised to negative 0.03 raised to e raised to negative 0.03 t. So since we have now ln, we can now bring down this exponent. So this is the ln of 98 divided by 99 is equal to negative 0.03 of the time multiplied by the ln of e. So again, we know this value, ln of e is the same as 1. So to compute for the time, we divide both sides of the equation by negative 0.03. So we'll be having, let's say, the time will be equal to, okay, this is the ln of 98 divided by 99. This is to be divided by negative 0.03. That is 0.3884, 0.3, again, 0.3384. Okay, 3384 minute. Alright. So this will be our solution. So it will take 0.3384 minute. For the amount of salt in the tank will be equal to 2 pounds. So this will be our answers for this example.